Hi, everyone. My name is Curtis Reese. I'm a Principal Solutions Architect at AWS focused on containers NAT modernization.
And I'm Sandeep Goswami. I'm the Principal 5G Solutions Consultant at Dish Wireless.
And you were in DOP 313. This is best practices for securing your software delivery lifecycle. Thank you all for coming today. I realize this Caesars Forum is a bit of a hike, so I appreciate the fact that you give us your time this time of the day. Hopefully this is a very interesting talk for you. To kind of kick it off, what I want to start with is a quote. Good intentions never work. You need good mechanisms to make anything happen. And today, what Sandeep and I are hoping to do is show you some good mechanisms that you can leverage to help build security into your software delivery lifecycle so that you can build more secure applications and you can build a lot more sustainable and reliable applications as well. To get it going, I'm going to put a little bit of context here. So I want to talk a little bit about DevOps and putting security into DevOps. And chances are, the reality is it's already been there, whether you're calling it out or not. When we look at DevOps as a topic, it's kind of one of those words that, depending upon who you talk to, it means one thing or another. I want to make sure we're at least level setting. And so when we look at DevOps, there's essentially a few pillars. So the top of the pillar is the business. The business is essentially the customer here, and they're representing the business's customers. So they're the ones that are setting a tone for what is it we need to build, what are the requirements, what do we need to include in it, and they're the ones that are making the decisions that come down to the other pillars. So on the left, we've got development. The development teams are in charge of actually building to those requirements. So they're going to build the applications, they're going to maintain the quality, and they're going to try and maintain a speed and a cadence of development that meets the needs of the business and its customers. But we also have the operations team. And the operations team, their primary task is to maintain server reliability and service stability. And so their job is to keep things up and running so that the customers are getting what they need and the business is getting the outcomes that they want. But the reality is there's a third pillar down at the bottom, and that's security. And oftentimes we treat that as a separate thing that's kind of bolted on after the fact, and I'm going to talk about that in a little bit. But the idea is that this security should be a native part of your DevOps story. And their job is to make sure that we're testing for security throughout the application, that we want to prioritize preventative controls and put those in place to ensure that the applications and the development processes are secured in a way that makes sense to the business. So how do we secure the entire development lifecycle, not just something kind of towards the end. And when deploying a detective security control, we want to ensure that it offers the right security responses along with it. So not only are we putting in the control, but we're considering how we're going to leverage that control and what impact it might have across the other pillars. Okay. And why are we doing this? So DevSecOps, and that's the way I'm going to refer to it for the rest of it, just the rest of the talk, just so we have some clarity there. DevSecOps is essentially a bunch of different things. So it's a combination of cultural philosophies, patterns, and practices that can be used to exploit advances in automation. So the idea is that if you're doing DevSecOps properly, it's almost entirely automated. And we want this to be done throughout the entire life cycle, as I mentioned. So this isn't something that you bake in at the end. This is something that comes in early in the development process. And so we want this before you've even written code, because the security requirements of the application are just as important as the integration requirements or the server requirements. And so you should be making these considerations. And chances are you're doing it today, you just may not be calling it out specifically. But here's some of the examples of why we want to do this. By implementing security, we make a much more secure application. Duh. Like, it's pretty clear about that. Like, what we want to do is reduce the risk for your applications and your customers. We want to make sure that we're putting things in place that limit any blast radius or impact for them if something does go wrong. We also, like I said, want this to be automated. So there's an agility that you can get to it. So if you build it into your entire process, it's not something that you have to hack in after the fact, or it's like, oh, we need to cut a space for this and make room for it. And that might be invasive into the processes. I mean, how many of you have been a developer in a room where you're 3 months into an application and then somebody comes in and says, oh yeah, by the way, you need to add this piece for security? How many of you have had that? Like, I've had that numerous times. It's a very invasive process, and it would have been preferred had you started from the get-go with that. And so it aids in that agility. It also makes it easier to get buy-in from various teams if you're all speaking the same language earlier on in the process.
Yeah, and just to add to what Curtis has been saying, I come out of telco. I've been in telco for a very long time. This idea of bolting on is real, right? A lot of what happened in telco legacy world is people bolted on capabilities, and the net result of going that route is you actually can end up with service impacts. Your service is not as good as it could be if everything was built in from the ground up and integrated organically. So as we go through the presentation, I'll talk a little bit about how we are taking these practices and capabilities that AWS provides and baking it into a real-world implementation of our network. So, Curtis?
Perfect. And so there's a couple things that we want to talk about in when we look at this in practice. So there's, again, we're talking about securing your pipelines and your delivery lifecycle. And so there's security of the pipeline itself, and there's security in the pipeline. And what this really means is that security of the pipeline is treating the pipeline as its own application and its own code base. It's going to have access requirements. It's going to have integration requirements. It's going to have security credentials that are going to be a part of that. And we want to treat that piece the same way we would the applications it's going to build within it. And then we have security in the pipeline. So this is where we're doing the CI/CD processes. This is where we're doing integration testing. This is where we're actually doing the security of the workload itself. And so I'm going to go through some of the patterns here, and we'll talk about this in a little bit more detail. Anything you want to add?
No, so the only thing I would add here is it actually creates a benefit in the telco example. And I'm a telco guy, so I'm going to stay focused on that. But I think the examples apply in other industries, other areas as well. But doing this also reduces the possibility that you will end up creating errors. You will introduce vulnerabilities. So having pipelines and pipelines that are secure and have visibility into what's being done, when it's being done, who it's being done by, I think that goes to your access control on the pipelines, is a big benefit in terms of having control over the environment. And a service like telco, oftentimes parts of a telco network are regulated, and the first thing that happens when there's a glitch, AT&T example from today, I think it's in the news. I don't know if you guys saw. But look it up. I'm not going to say anything more, but you can find out what happens when there's a security breach in the network. But we are regulated. We need to make sure this stuff is good and clean.
Yeah, you want to be able to attest to it and audit it as well, and we'll talk about that as well. So when we look at security of the pipeline itself, it's that idea of treating it the same way as the code base. So if any of you are developers, you understand that process. We're going to commit code, we're going to do code reviews of it, we're going to go through and test against that code, and then we're going to validate that it's doing exactly what we expect it to do before we push it out to production. And so the idea here is we're going to treat our pipeline that way. And so we want to implement a pattern of least privilege. So if we think about it, our pipeline is going to have access. So who on the development team needs to have access to that pipeline? And what level of access do they need? So as developers in the development environment that are building the pipeline initially, they might need read-write access. They might need wholesale control over it. But once they mark that as done, it needs to move up to the next tier. And from there, maybe it's read-only. And so you have to consider things like that. So maybe the development team needs to be able to go in at a specific spot in that pipeline and check that things are working the way that they want. But you don't want them going in and say, adding another stage to the pipeline in real time or on production or adding another code repository on the fly. Like, you wouldn't want people going and doing stuff like that in your code, like swapping out a library on the fly. Like, it doesn't make sense. And so treating your pipeline the same way is important. And kind of to Sandeep's point, when we have the infrastructure and that pipeline in code, you can attest to it. You can validate it. You can say it's specific versions. And so there's a lot of auditing and governance that you can put in place there early on to make sure that it is what you say it is.
Yeah. So if I can really add in 10 seconds.
Sorry.
So there's actually, in the section I'll be speaking to, an example I'll go over of how we are implementing this, using the capabilities that AWS provides us. So I'm not going to do it now, but I just want to set it up.
Perfect.
Yep.
And so this slide is a little bit of acronym soup, so I apologize for that. But these are a lot of the opportunities when we look in the pipeline. So if we look at security in the pipeline, you have a lot of opportunities to implement security practices within there. And so one of the earliest ones, and I want to be clear, you don't have to do all of these. Like, the goal would probably be to get to most of them, but you just start small and start kind of higher on this list early in the process. And so one of the first steps is protection of sensitive information. So this is when you commit your code, doing some kind of scan against it to make sure there's no secrets in it. There's nothing that you don't want publicly accessible or exposed externally. And as we go through this, and I'll break this up into a slide later on, but basically the idea is you have the opportunity to do static analysis testing or static code testing, dynamic application testing. You can do inspecting of the actual running application and doing performance analysis to identify potential issues of the code itself. And so these are some of the benefits that you have or some of the processes you have at your disposal. And I highly recommend, if you're not doing these, at least look into what they are, and we'll go through a few of them today. So what are some of the patterns we're seeing here? So when we look, when we look at integrating security of the pipeline itself, it's like I said, you've got your code base, your infrastructure architects are going to be in charge of that code base. They're going to be creating some kind of CloudFormation template or maybe a CDK based application that's going to be defining their infrastructure as code, or you're going to be using something like Terraform. All of that should be in a version state. So that you know exactly who made what change to that application, what did they change. Once it goes into a code commit repository or a Git repository, then you can do certain scans against it. So imagine if you could do a scan that says, did they open up additional ports? What were those ports? Did they create a security group? Is it an allowed security group? Is that something that we want them to do? If it's the pipeline itself, what stages are they adding? This gives you a lot of control and flexibility for you to go through and actually verify that it's following the patterns and practices and even the style guidelines that you want for your particular your code base and your pipelines. And as we go through that, you can actually do integration testing. You can go and build out these pipelines. You can test them. You can do linting against them. There's a number of tools that we have listed here, such as CFN Lint, CFN Nag, CFN Guard, and TaskCat. These all give you a lot of flexibility in going through and identifying some of the common things that you should be looking for in your templates and making sure that everything is acting as it should. And I like to call out CFN Nag because I'm on the partner team and it's made by one of our partners, Celligent, and it's incredibly useful for inspecting for common security issues with your templates. And we're here to talk about security. Definitely take a look at the opportunities there to scan your infrastructure as well.
Yep. Now, and to amplify the ability to do things like scan for open ports, that's how people get into networks, and we need to make sure we have that capability. So, how many of you guys are familiar with what Dish Wireless is doing? I know Mark was on the keynote yesterday, but people familiar with Dish Wireless? No? Not many. Well, that doesn't surprise me. Dish Wireless is entering the wireless space with a cloud-native 5G network, and I'll talk more about it, but in any network, leaving aside Dish Wireless, these are important things, and they have actually caused issues in network, exposing data, taking down service. So the stuff that's intuitive to you guys, you're all developers, you probably do this. Bringing it into telco is what Dish is doing, and it just makes for a better overall product, we believe.
Well, and that's the ultimate goal, is you want to make this as streamlined and seamless as possible to improve the overall product. And when we start to dive into the actual pipeline itself, like what are we doing within the pipeline? So this is a standard pipeline for an application. You see the teams on the left, moving through the code repositories, through our integration testing and our build environments. There are a couple different tools that you can use on top of that, such as Code Artifact, Code Guru from AWS, and even ECR. ECR, if you're building a container-based application, ECR can automatically start scanning your images for known CVEs. There's built-in capabilities for that. And the idea is you have a lot of opportunity here throughout this entire life cycle to start injecting security processes. And so the first one that we're going to talk about when we look at the continuous delivery pipeline itself. So if you're building this in code pipeline, I'm going to have a couple of these slides up here. They're a little bit more just for your information, so if you want to take pictures of them, it's great. I'm not going to talk to every aspect of it, but you'll see a consistent trend. As you create a resource, there's going to be some kind of resource ID associated with it. And then you'll have permissions that you can use against that resource or with that resource. And so when we're looking at code pipeline as a resource, there's a number of policies that you can use to control access to it. And it lets you get a little bit more creative. So if you look at your pipeline, you're going to have multiple stages. Well, some of those stages might need a manual approval. You can leverage the security policies to actually control who has access to perform those approvals. So say you have a continuous deployment or a continuous delivery process and you want to stop right before it hits production, but you only want a specific team to be able to make that final approval before it automates the deployment. You can control that via policies today. Another one is you can stop the stage transitions. So imagine if you had an AWS config rule that's set up as a centralized governance policy that says, look, any code pipeline should have multiple stages for multiple environments. So you should go from a dev environment to a staging environment to a pre-prod to a prod. You can leverage the policies here to actually say if somebody creates a code pipeline, it actually has to have that. And you can stop stage transitions for the ones that don't. So you can create a rule that says, look, this one's trying to go straight to production, stop it. And then you can report against that and you can make decisions against it. And so it allows you a lot of flexibility there. But when we look at what you get when you create it, you get a service role. And that service role provides out-of-the-box access to basically every service that interacts with code pipeline. And in a development environment, that's actually very helpful. You know, you're probably still in the process of defining what your integrations are, what services you need to touch. But in a production environment, as part of the stage in your pipeline, you probably want to implement a pattern of least privilege. And so this gives you the opportunity to restrict access over time as you evolve your pipeline and get an understanding of what your application needs to restrict access to what your pipeline can actually hit.
Yeah, and again, I recognize that you guys may not be telco, but lived real examples where people went and made changes in production, especially when there was an outage going on that nobody knew about because they were not access controlled or we didn't have these rules in place. And there were definitely no pipelines in the world I come from. So that kind of stuff can come back and be a big problem. So nobody knows what was done, and suddenly your network is now built in a way that people don't know. And it just is a problem that I think the pipelines help address.
Yep. Actually, I do want to cover that last one. So your pipeline also needs access to services. And so imagine your pipeline needs to connect to something that requires credentials. What you want to do is use things like parameter store or secrets manager to abstract those secrets away so they're not exposed in the pipeline itself. And that's the same with the pipeline as code. So in your CloudFormation templates and other, whether it's a CDK or Terraform, like you have the opportunity to abstract those away and store those in a secrets or management solution. And you want to treat it the same as your application. So get it out of there so it's a little bit more secure. And so when we look at the pipeline itself and we start to secure the actual applications that are going through it, the first opportunity and the most obvious one, like I said earlier, is scanning for secrets. So as your developers are actually committing their code into their code repository, whether that be code commit, GitHub, Bitbucket, whatever, the idea is you should be triggering some kind of scan on that code base. So whether it be on a pull request or the code base as a whole, you want to go through and make sure that you're actually scanning for PII and other things in there. So is it secrets? Is it operational data that you don't want exposed? Like it could be basically anything, but you want to basically go through and make sure it's not a part of that code base. And so we have tools that you can leverage that do that, or you can write your own custom scripts that go through and search for known things that you as an organization don't want in there. But you have a lot of flexibility there. And when we look at code commit as a tool, it itself, like the previous one for code pipeline, has a resource. And you're going to have control over who has access to that repository, whether that be a developer on the team or a third-party solution that you want to integrate, whether they're going to go through and do a scan on the code base that's in there. You have a lot of flexibility over who has access to it, what level of access, what tasks and actions they can perform on it. And you have a lot of control over this with the exception of one. All code commit permissions, you have control over all code commit permissions except for list repositories. You either have it or you don't. So I want to be clear on that one. So if you have a user that's in the system, they can see all the repositories, or they can see none. So that's the only exception. That's the only little gotcha. And most of the users that you're going to provide access to are going to access it in one of two ways. So there's going to be HTTPS, and that can be tied to an IAM user, or you can leverage an assumed role via the credential helper in the AWS CLI. And then the other option is an SSH key. And so most of you are going to be familiar with that. It's a pretty straightforward process. You can see an example of the code commit repository page here, where you can specify that for that specific user and actually download the credentials or update them as well.
Keep going.
And then as we move forward to the rest of the CI/CD process, I realize there's a lot of stuff that we just added here, but if you think about it, you're doing a lot. Like after you've got that code ready to go, you actually need to start performing actions against it. Like you need to actually build it. You need to test how it runs. So maybe we've gone through and secured the code itself, but what happens when it's executed? Is there something that we missed? Is there something in the way that it's running that we want to secure? How do we know that while it says it's doing this, it's actually doing that? And so what we want to do is go through and do static code analysis. We want to do application testing on it. We want to do linting to make sure if this is the linting phase of an application or an infrastructure as code process, they're actually going through and linting that in the continuous integration process. And again, like I mentioned, you can feed this up to something like AWS Code Artifact or an artifact repository, which can then go through and scan your compiled code, can scan it for known CVEs. You can use something like CodeGuru, which I'll go into a little bit later, that can actually help you profile the application for known and common vulnerabilities, or you can actually do a scan of the code base itself for anything that might be not performant, or maybe you've got a scenario where you're not scanning for user input, where you're not going through and making sure that it's being filtered or doesn't include any vulnerabilities that way.
Yep. So we are, the thing Dish is doing is building the network using software. So I'm not going to throw a bunch of technical jargon at you guys, but our approach to building the network is fundamentally different than the legacy world, where people bought basically a fully integrated component. Think a router with the software and everything integrated into it. We are taking a fundamentally different approach. We are buying software and we are deploying it on infrastructure from AWS. Now, why is this important in this context? Our software is going to come from a variety of suppliers. We have announced a lot of them. Nokia is one of them, for example, Matrix, another. So they will do exactly what you guys do when you're developing software. They'll deliver code, updated code, into our repos. And we are leveraging the scan capability. We are leveraging tagging to basically analyze the software, make sure there's no issues in it. And then we are leveraging it also to trigger pipelines for us. So I'll talk about it a little bit more later in the presentation. But the telco world we live in, the one that we are building against, is full software. And that's where these things become just as critical as whatever industries you guys are working in, where software is being developed.
Yeah, and that's actually a very good point, where a lot of the teams that you guys are working with today and gals are working with today may not be just your teams. You might be consuming software from third-party vendors. You might be consuming things downstream. I had a scenario probably 6 or 7 years ago now with Node.js, where a common library was changed downstream, and we weren't scanning for that. And it eventually affected us from a security standpoint, because we were just looking at our immediate code, and we're including all these other libraries. We're sucking that in. The security vulnerabilities came with it. And the idea of leveraging something like an artifact repository and a scanning solution to basically pull from your vendors, scan it, make sure it's the version you want, make sure it's not vulnerable for any known vulnerabilities, and then suck that into your own artifact repository and start pulling from that locally, that's a process that can actually save you a ton of money in the event that there's an issue. You might not be one of the ones that ends up getting affected if something like that happens. I unfortunately was in the boat where we were affected and it took down our application. I actually had to talk about that yesterday. And so as we go through this process and we move out of our integrations and we start going into the actual build and deployment processes, we've got opportunities to actually take the built artifacts, the built images that you put out there, and actually perform testing against it. Like I mentioned, you have CodeGuru. That's a great opportunity for you to do profiling of the running application. But you can also do load testing on it. You can do penetration testing. You can have third-party scanners that can come in and actually scan it for known vulnerabilities from an actual running state from the outside. And we've got a couple tools that will help you with that. So if you're producing an image, you can push that up to ECR and you can actually scan it. We have a number of third-party ISV partners that will actually scan those images, and they'll actually scan your running applications running on your instances. So they'll come and do runtime access scanning. They'll do file access scanning. They'll do file level heuristics to make sure what you attested to in the actual application code is what actually gets run there. So these are things that you can probably you should be looking to do at some point in the life cycle of your application. And then as we go into this and look at Code Build, Code Build is a phenomenal tool. How many of you are using Code Build today? Awesome. Thank you for using that. We have a number of other partners that'll actually provide this as well. You don't have to use Code Build. But for those of you that are using Code Build, the way that it works is you essentially get a Docker environment. And you have a lot of control over what goes into that environment. And so you can control the encryption keys that come along with it. It will create a resource for you, and you can control access to what those environments have access to. So you can create policies to say, look, this Code Build environment can access this set of services, or it can connect to these things on the network, or it can connect externally to be able to access certain third-party solutions. And you can provide a lot of control over who has access to these build environments. And so if you think about this, this is a common threat vector, not just Code Build, but I'm saying like this part of the build process is a common vector, where if we're bolting on security after the fact, a lot of people will see that. Like a lot of nefarious people out there wanting to hack your code, they're probably coming at it from the outside in, or you're testing thinking that they're gonna come that way. But they look at your process, your build environment may be completely wide open. Well, they can just inject whatever code they want in your build process, build it into the compiled application, and push it out. And so you're over here testing for this, but the vulnerability has already been put in place. And so we want to make sure that you're looking at this and having a lot of control over who has access to the build environments, verifying the build environments themselves, maybe scanning the repositories for those, and then limiting what you put on them. So it's the same way you would build a container, or the way we approach even BottleRocket OS. Strip out what you don't need, only include the things that you do, and then make sure that you're validating those processes along the way. And the same thing with Code Build is you have access to third-party solutions, and because of that, you need to consider things like secrets management. And for this, you can leverage parameter store as well. We've got an example of just a simple way to actually reference that here. You can provide environmental variables as part of your spec for it, and then you can just reference the parameter store variables that you want to incorporate. It's very straightforward, very easy. It's something that if you're not doing today, definitely start looking at it.
Yeah, and actually we are leveraging the parameter store in addition to the aspects that you highlighted to also abstract out things that are specific to locations or sites, and still streamline the code. So the code can be common, and when we are deploying at multiple sites and some aspects of the configurations need to change, we use parameter store to do that. So again, the security is clearly a highlight here, but it also helps with agility for us, as a telco operator trying to build the network. So.
And so when we look at this holistically, we want to make sure that you're taking opportunities at every phase of the build. And as this continues to move forward, we're going to actually go and run this application in production now. But like I said earlier, your security posture on this shouldn't end there. This gives you the opportunity to, as you've built the application, sign the images or sign the code that you want to execute, and then use that as a way of verifying and validating your deployment processes. So if you're working with Kubernetes, you can sign your images and make sure that what's actually being deployed to your Kubernetes cluster is what you specified in code. And so if we've shifted everything left in that process and everything's in configuration as code and it's all versioned, you can actually say, what's over here should be what's in the code base. And you can leverage opportunities like GitOps to basically validate that. And if it detects drift, fix that. Put it back in place as what you would expect. And you can implement things like OPA policies that say, hey, if this doesn't match, block that from being deployed. It kind of does a mutation in the admissions controllers to go through and actually validate that for you. And if things don't match, it doesn't get out there, and you alert your security teams, and you can actually take action against that. And then as it's in production, you can deploy dynamic application testing. So this is where you could use fault injection simulators or chaos engineering to come in and actually test it for known things and experiment with it in a production environment based on the way that you anticipate your application should be running. So you've got a lot of opportunities here. These are just some simple examples at each phase, but we just want to plant that seed so that you're thinking about this. It's like, this isn't something that you just have to worry about. Like, once the application's up and running, am I scanning it in production? Are we monitoring for changes to the actual file systems? Are we monitoring for that? Absolutely do that, but make sure that everything before it is actually being considered as well, because if you're only doing this, you're still vulnerable all the way down to the left. And then if we look at code deploy, it's the same story. You've got code deploy will actually handle the deployments for containerized workloads. It'll handle the deployments of compiled applications directly to the EC2 instances. You're going to get a deployment group as that particular resource, and then you can have a lot of flexibility and control over who has access and what that deployment group has access to. So you can use things like IAM to control the applications, the application revisions that it can deploy. You can control the actual deployments themselves, and you can even control how it deploys to instances that are on-prem. So you have a lot of flexibility and control there, and you should be following things like a patterns of least privilege. So it shouldn't have access to everything. It should have access to the very specific things that it needs to deploy to limit that if somebody got into the deployment process somehow, you're still narrowing down what they might have access to get to. And then, yeah, this is just more of the same. So it's just making sure that you're leveraging service roles wherever possible, and that you're leveraging your IAM policies to limit who has access to those. Everything can be defined in your AppSpec YAML, which is included in your code base. And in that AppSpec YAML, if there's something that code deploy needs to have access to, you can specify those secrets in there and reference it to parameter store just like everything else. So again, if it needs to log into something to be able to go and actually do the deploy, or something needs to be run or executed as it's deployed, it'll go through and actually leverage that on that account. And basically, we're through the entire pipeline, and now there's the opportunity for you to integrate into Security Hub. So any of the processes in here can actually feed the event stream up to Security Hub. So if any of these have a failure, any of these have an alert or an alarm that you want to know about, say something did fail in the build process and we want to flag that, or we've noticed something in production that's a little bit wonky, you can alert that through Security Hub. And you can also alert it through, you can monitor that through CloudTrail and other integrations as well. So again, the whole pipeline, all the opportunities you have here, this is what it looks like. And with that, I'm going to let Sandeep talk a little bit more in detail about what Dish is doing with security.
Yep. Well, I'm going to talk more broadly about what Dish is doing and how we are doing what you pointed out at the very beginning, Curtis, which is not taking aspects that are tied to security and approach it as a bolt-on, right? Mm-hmm. That is where I'm going to focus a little bit. But before I get deeper, and this might be helpful for some of you guys since you may not be familiar, Dish started this journey about I would say about 18 months ago, 18 months, 2 years. But we are entering the market as a fully containerized 5G network. It's cloud native. It's going to leverage all of the things you talked about in terms of being a software, everything being software, everything being deployed by code, least privilege, multiple environments. So I'll get into some of that stuff. But the reaction we got when we first made the announcement was that's not real. That's not going to happen, just like the previous examples, right? So everybody knows, Tesla came, the first car, the Roadster, it's a fad car, never real. And I don't need to tell you guys what's happening in those spaces. So what I'm going to say is we believe that this was possible to build a completely cloud-native 5G network. Several months into the journey, it's a conviction. We know it can be built. In fact, we are live testing the network in multiple places, including here in Vegas. So it is definitely possible, and we are continuing to execute on it. So, why is it hard to do something like Curtis is talking about, fundamentally in telco? The problem is this. I already said, telco is not a single software stream. We consume software functions from multiple suppliers. And the way this has been managed in the legacy world is you had very defined upgrade cycles. You did not touch your network. You never did anything to it. And if you made changes, you made them in a very structured and, by extension, really slow manner. Upgrade cycles for even one component in the network would be a months-long project. We don't want to do that. We want to basically bring the practices that exist in so many different places, web apps, you make changes. Netflix does stuff, chaos engineering in production, right? That kind of stuff. So we think that's going to be a fundamental differentiator for us, but this is our problem too, that we have so many suppliers, so many components. A network stack has 50, 60 more functions running that have to all operate. So we are leveraging the capabilities Curtis talked about to address that problem and move forward. When we started the journey, we learned some really important lessons, and I'll tie it to the why it's important to do these things from a security perspective. But we talked to the standard cast of characters that operates in telco, and everyone was talking cloud native, every single one of them. They were talking, we are cloud native, we have software only, you can have it, but they also came with their own curated stacks. They brought, I'm cloud native as long as you run my PaaS, my CAS. So that's perfect for them because they control it, they test it, they can guarantee performance, but you cannot build a network that way. So if you're wondering why the other telcos haven't done this, one part is they have legacy baggage. Second, you cannot do this. So that's when we picked a partner like AWS to say, no, we can do this, but we can't go down the path in this posture. So what we did was we standardized the stack. And a lot of the things called out here, like EKS, and then the use of Multus, there's multiple different ways of doing CNIs in software, but we picked a standard stack, and we forced our suppliers to adhere to that. And to link it to the security aspects, then we control what's coming in. So if there's a bug in one of the plugins that they're using, your Node.js example, I think, was the one, right? So somebody may use something that we don't know there's a bug in, they may not have scanned, shows up in our network, and we have a problem. So that's why we standardized. Then to get the agility we are looking for, we abstracted out with the help of several people from the AWS side, services team and others. We abstracted these out. So that gives us speed, but that also, again, has control, and control links to security. You don't have people doing things they are not supposed to be doing, and then we automate it. So that is the construct that's allowing us to continue to move forward with building a telco network in the cloud. So in this context, how do we solve for DevSecOps, using your term, right? So you talked about the stages of pipeline. Mm-hmm. You go from dev to staging to pre-prod to prod. We've taken that and put it on steroids, right? We are actually doing this for our network itself. And there's a term that was introduced by Mark yesterday, network of networks. This is how we are doing it. We have, with the public cloud, with AWS, we don't have the constraints that exist in a regular telco environment. Telco guys have tried to do this by building private clouds. You're always constrained by the resources. You're always constrained by, can I build that many data centers? Can I build that many environments? And the answer is no, they don't. So it's a very traditional posture. Maybe called cloud native, but you have two environments. One doesn't look like the other. Your lab never looks like production. I think you're shaking your head, so you probably know what I'm talking about. Maybe the only guy in the room. Now, so if you're on the engineering side of this, it literally means people only trust production. That's the only network, and you can't do anything other than fix things in production. Like, I'll not go into the weeds, but what we are doing is we are building these environments, and we are starting from the bottom. So we are actually forcing our suppliers to develop against the target environment. So the sandbox is at the bottom, and then it goes up from there. So integration environments exist, then each one is gated, and everything is controlled by the pipelines. And the security aspects are baked into the pipeline. So we have the same IAM access, all of the things you talked about, code scanning, image signature scanning. We leverage all of that stuff to basically control these environments. So I'm going to click through. I kind of had a little faux pas there. So we have these environments. We use pipelines. We use controls. We use all the security best practices that Curtis talked about. And taking it to an extreme in production, we are not allowing people to touch production. Okay? It is through the pipeline, and then that gives us the ability to block it, something doesn't look right, right? We are limiting external connectivity to the environments and using constructs like security VPCs to have choke points. So despite best intentions, if you will still have problems. And the idea of introducing security VPCs gives us the ability to have choke points. So we can, in a bad scenario, we can control the damage. The last thing I'm going to say is, in addition to all the capabilities that come out of the box from AWS, the access to repos, the least privilege mechanisms, security groups. We are leveraging all of those things, but we are adding to it. We are extending it further. For example, in the repos, we run something called Twistlock to do additional scanning of the software.
I believe that's Palo Alto now.
Yeah, that is Palo Alto, yeah. In our production workload, so Curtis talked about how you do your image validation, the signature validation before it goes to production. We actually deploy components next to our functions in production that are actually checking for malicious behavior when it's live. So we are doing things like that. So taking it collectively and in partnership with AWS, I think we are, building the network with true DevSecOps, right? So I'm going to hand it back to Curtis.
And I imagine that by taking control of the stack and shifting kind of left in that conversation and saying, like, look, we're not going to just take any random integration. We're going to control that. Gives you a lot more flexibility and control to implement some of these patterns and practices, correct?
It absolutely does. And it also gives us agility. Even though the focus is security, there are benefits. Your product's better, and you get way more speed than you would otherwise. And that's a competitive differentiator. We can introduce capabilities in our network that I had said earlier. Doing something like that in legacy would be months, years. So that's why we believe in this vision, and we are executing it with your help.
Yeah. And imagine if you find a vulnerability, since you're controlling that stack at that point, you're not waiting for somebody else to go and fix it, or waiting for something that might affect their customers. You can actually have the agility to speed it up more quickly. Yep. And so where do you get started? And like I said earlier, there's a lot of really easy things that you can put in place today. There's a lot of very complex scenarios. You can see what Sandeep and the team at Dish are doing. It's very complicated. They've got pipelines of pipelines, and they've got lots of ISV vendor integrations. They're controlling the nature of the relationships with those vendors and actually dictating how they're building the software so that they can build it in a faster, more agile way. Like, you can start with something that's just as simple as turning a checkbox today. And so that's where I want to focus on today. But you've got a lot of opportunities at various phases. If you're already implementing some of this, congratulations. Try and move up the stack and see if you can go later in the process. One of the ones that I want to say just turn on today is Amazon Code Guru. And the way that Code Guru works is it's a machine learning based DevOps security solution. And so basically it works in two ways. There's the code reviewer, so it'll actually go through and review the code itself. And so it'll identify any particular vulnerabilities that might exist in the code. So it's going to do an analysis of that code and then basically let you know some insights about it, what it finds. So if it sees something that's common, it's going to say, hey, you should probably change this, and here's a recommendation. And I'll show you that in a moment. But then it also has the profilers. And the profilers run during the build process. So when you're actually doing build and test, so it can actually identify any any non-performant pieces of code that are in there, or it can also help identify any common security activities that are being performed in the code base itself. And then as you go and deploy that to production, it can monitor that in production as well. So you can continue to identify any costly pieces of code, things that might be a performance bottleneck that might be throttling your application or causing issues. And you can use that, and it's going to provide the same level of insights that way as well. So it will identify that, correlate it, and share that upstream with you. The categories of security issues that it'll find in your code are as follows. So it can leverage, or it can identify misuse of specific APIs. It can look at weak encryption. So if it's looking at, say, a Java application, it can identify scenarios where you're using weak encryption in your code, and it can highlight that. It can go through and look for sanitization of code. So if you're not doing sanitization of SQL inject, which all of you should be doing at this point, it's something they can do just by clicking that box and allowing it access to your code base. And the same as you get with a lot of these services is we built this based off of what we were seeing at Amazon and AWS. And so it comes kind of with the best practices that we've learned from running our sites and services. So you get to leverage that just kind of out of the gates. And then it's going to honestly, because we keep saying this over and over again, it's going to identify PII. Turn that on so you don't get the credit card information or other stuff that could potentially be exposed. One example of the way this works is we've got a code sample on the left. It will go through your code repository. It'll identify the code. In this particular scenario, we are looking for getting an AWS account ID. But if you notice down below, we are logging that error out as potentially plain text. So there's a chance that if there's an error in your code, you could actually output sensitive information, plain text, into standard out or wherever you're logging this to. So it'll go through and actually see that and say, hey, you should probably use the redact function on that. So we can actually redact sensitive information. And then it's going to actually provide your developers in the code itself, like in the pull request, it'll actually respond with a comment basically saying, hey, here's some recommendations. And so go research this. It's going to try and give you some insights. And the way it works is it's got access to your code repository. So it can communicate directly with Code Commit today. It can also communicate out over the internet to GitHub as well as Bitbucket. And it can actually operate via pull requests. So you've got 3 different ways. So pull request, code commit, pull request, runs its scan, responds back. Another one is you can do ad hoc on the fly full repository scans. So it can go through and scan existing repositories. And then you can integrate it within CI/CD processes. So as you're going through and performing specific actions in your CI/CD process, you can trigger an inspection as well. Pretty straightforward process. It can also communicate with local repositories. So if you want to connect to something like GitHub Enterprise on-prem, it has a mechanism and it'll provide you instructions on how to actually go through that via the console for it. It will connect down through a VPC in either a direct connect or a VPN connection to your corporate data center, so you can actually contact that and communicate through that process. And the workflow is basically this. Your developers will actually commit their code. They'll create that pull request. It'll actually go over to do a PR notification to the Code Guru service. The service will review the code and it'll actually respond back saying, hey, here's what we found in the code base, and you can respond accordingly. But you don't have to do that on our services. I want to stress this. I represent our Code Suite services most days, or our container services the other. Use whatever tools is going to work for you. An example here is GitHub Actions. So you can have the developers commit to their GitHub repository. The GitHub action that's going to trigger the build can actually go through and push that code base to an S3 bucket. then do a notification to say, hey, Code Guru, go take a look at that S3 bucket, and then respond back. And so it'll provide feedback to the build process there. Some upcoming integrations are GitLab, Jenkins, and AWS Code Pipeline itself, but we actually have the support for that. So that's basically all I have for you today. I don't know if you want to add anything to that.
So not to that, but at the end I will.
Okay. So the idea here is there's a few things that can be a call to action. So one, if you're not doing these things today, start with the things that are going to be simple to implement that aren't going to cause a lot of friction, and start talking with your development teams and your security teams as early on in the process as possible so that they're being seen as kind of just at the table the whole time. That will help with those conversations later on of like understanding what each requirements are. I've sat in so many meetings in my past life, not just at AWS, where the teams just don't talk to each other. And so they don't understand the requirements. And so it's one of the challenges that we're faced with DevOps and why the concept exists. All of these people are tightly coupled. They're tied at the hip. They should all be a part of the conversation, and their requirements need to be heard. But in order for the requirements to be heard, they also need to be understood. And so the best way is, I use an example of, I used to walk into my network ops team, where the apps team would want a specific port open, and they would just say in their request, open this port on this particular application. And the networking team would just look at it and go, no. And they would just move on. And the apps team and the development team would be furious. It's like, I asked them to do this, but you didn't explain why. Like, you didn't explain what you were trying to do. You gave no requirements as to what the input and output of that would be. Like, what is it going to connect to? Who is going to connect to it? How are they going to connect to it? Why are they connecting it? How are we going to audit that? It creates a lot more knowledge for the developers because now they understand, like, hey, I have to consider these things. But it also helps the other teams understand how they're being leveraged and be able to say, hey, we have some requirements around that because if you do this, you're going to expose this, this, and this. And together we can have a conversation around that that's far more meaningful. And by doing that, we can implement these processes a little bit more cleanly. So go ahead and take a look at some of the resources we have here. You can sign up for Code Guru today. It's available for you to use. We have another session here that's DOP 401. It's continuous security and compliance for your CI/CD pipeline. It's a workshop. If it's not available, if it's already past that date, most of our workshops are available at awsworkshops.io, I think it is, where they should be available online so you can take them in your own accounts. So those are a couple different options. We also have some sample applications and code that you can leverage and some useful blogs. So these will actually, I believe the decks are going to be available for you. So if you want to take a screenshot of this or a snapshot of this, I would recommend you take a look at it. Otherwise, you should be able to get a copy of the deck. And then in closing, is there anything that you want to add?
Yeah, I do. So the last thing that I'm going to leave you guys with is, first of all, thank you for coming here. There's a lot going on, so I appreciate that you were here. I want to close by amplifying the theme and what you said about understanding requirements and leveraging best practices by saying Dish is so focused on that aspect that we are prioritizing it above testing the actual network function capability. And the reason is our suppliers, the Nokias of the world, the Mavenairs of the world, the people that we are buying the software from, we trust that they will deliver the capability, right? That's what has happened for years in telco. You get the capability, but you don't have the controls, you don't have the visibility, and you don't always understand the requirements. We believe it is so important that for us, that is the focus. We are accepting buggy software, and we like bugs. Again, to steal a common phrase Mark Ruan uses, we love bugs because that's something we found and we can fix instead of it being in production. The legacy posture has always been, I got it working in production, don't touch it. Don't touch it. I don't care. It's working. Just don't touch it. And that's where we are shifting the landscape in telco. We are so focused on the collaboration, understanding the requirements, ensuring we have the agility and the best practices baked in from day one, that we are accepting software with bugs because we know our partners will fix that and the network will work. So that, to me, is a manifestation of everything you've been talking about in this. So thank you again. Hopefully there was some more telco people besides You? Thank you.
If not, we will be available to talk out in the hallway afterwards. I do want to thank you all for coming. I know you probably hear this at every single session. I don't know if people are going to say it this way, though. The surveys themselves aren't just a grade for me. I'm not worried about the grade for me. Be as constructively critical as possible for me. What they're used for internally, though, is they help us understand what content to produce based on your feedback. So it goes to our service teams. It goes to our internal field communities. And so your feedback saying like, hey, this talk with Sandeep and Curtis was good, or it was great. What I really want is this. Like, it would have been great if they'd gone deeper in this area, or could I have seen a code example here? That kind of feedback actually makes it to the service teams. It makes it back to my team so that we can decide, should we create immersion day content for you focused in that area? Should we create code samples for you? Like, it's a great avenue for you to give us feedback on the things that you actually want and see, and it doesn't just go into an Excel spreadsheet somewhere. I actually have to sit through multiple meetings for that. So I encourage you to fill that out. Give us some candid feedback. If you don't think you got what you wanted out of this session, please stand over here and ask us some questions. I want to make sure that you walk away with something more valuable. And I appreciate the fact that you had a lot of time this week and you chose our session. I hope you have the great rest of your week, and I hope you have a great, safe week too. Thank you all for coming.
Thank you.